All right. So you'll notice in your review some things on polynomials because you've got to thoroughly understand polynomials to do what we've done with rational functions first of the year, and it's like what you do basically all the time. I even have shown you, it doesn't have to sink in yet, but even how we can have something called Taylor and Maclaurin polynomials that model what we call transcendental functions like sine and cosine and tangent. So polynomials are extra important, and so we had picked out some review for that. Which one was it, Isabel?
It was graphing.
Sketching?
Yeah.
Okay, so just a review of what you should know about polynomials. First of all, we have the pleasure of this one's already factored. Okay, and I know y'all know this really well from Algebra 2. This is a fourth degree polynomial. Okay? Because I have 1, 2, 3, 4. One of them is what we call a double root. It should be tangent to or bounce off the axis. Okay? It's got, by the fundamental theorem of algebra, it has 4 roots, but one of them is a double root. Okay? And we talked about the fundamental theorem of algebra a few weeks ago when we were doing complex numbers, because you were finding roots of things like x to the fourth, equals -1. There should be actually 4 answers to that. You could find all 4 answers in the complex number system. Okay, so some things about something with an even power. An x to the fourth, it's either going to go like this or like this, right? Only you just did this, okay? Odd graphs are going to do like this or this depending on their lead coefficient. Since my lead coefficient, if I multiply it all out, which I'm not going to, my lead coefficient would be negative, and so it's got to be coming from the negative infinity. Like as x approaches infinity and negative infinity, y approaches negative infinity. So anyway, what Isabel found is that every now and then when we drew it, we would get like an incorrect even when we did it together. And so let me tell you where we are. This graph has got to go through 1, 3, and -2. When it hits -2, it's got to bounce and be tangent to the axis. I've got to come back down and go through 1 somehow, and then come back through 3 and go back to where I came from, okay? And then when we submitted the answer, okay, so I got that one right. All right, here's the real one, and there's mine. Every now and then, Isabel and I, when she came to me, every now and then she would be doing this, and it would give her a red X, and she would think, well, now it's mandating, it's making me go however high. She came to me with the question of, how many points do I have to find? Because even if Isabella and I found a point in here, it doesn't necessarily mean it's our highest point, and it got really frustrating. Do y'all see her dilemma, like the loops, the humps? Which you need calculus for, okay? To find those maxes and mins. There's really not an algebra way to do it, because you just be guessing until you got the highest one. And that's not true, okay? So you should be able to practice this and everything's fine. I'll try to get one that I get a red X on, and we'll see what the problem is. And she, all right, so this is another one that's going to come from the positives, and it has 2 double roots. So at -1, I've got to bounce, and at +1, I'm going to have to bounce and then go off like that. And I hope it gives me an X. Okay? I was hoping that I'd done what I'd actually done. Yes, I know it's already wrong, okay? And so it was confusing at first, but it realized it does want your y-intercept. And so it's easy enough to fill in 0 and get the y-intercept and at least go through that point. I really did think that was going to be my error. I was trying to draw one on purpose this time that I'd done accidentally before. That wasn't even a function. Because the drawing's so cumbersome with your mouse then every now and then I would like have one. Do y'all see how that's not a function? So my guess is if I'd got my y-intercept right, it still would have x'd me out because it wasn't a function because I can't draw very well with my mouse. Okay, so do a few of those just to, get your feet on the ground. Nobody's grading or looking at your ducks and air. But I'm so glad things like that are happening and people are already starting to study. So you ought to be able to practice that. Find your zeros and your y-intercept and just do the best you can with your drawing. But I wanted to address what might be happening to you. All right, our slides of today are ready for the exam. All right, so let's pick back up where we were in the last class, where we were actively talking as class was ending, and I was throwing things out trying to hurry up and get it done as I was watching the clock. And I don't know if anybody noticed, I guess I could pull up the end of the other video, but let's move on. I had pulled one, well, let's look at it. I don't know if you saw me hesitate toward the end of class or if anybody noticed, I actually put one up that, you know how I was trying to prove, like, if it starts at 3, then if your sigma goes from 3 to 5, then you still want your a sub 1, and I'll show you what I was doing. You can certainly raise your hand if you notice this. Some people maybe have noticed what I did wrong, and time was ending, and you may not have mentioned it, but I need to address it. Because I kind of looked at it for a minute and go, that's not going to add up to what it should add up, but I needed to keep on going because I knew what I was saying was correct. And after y'all all left, I looked at it again. I may have saved my notes. That would be too smart. Let's see. I may have saved the file. Look at that. Cannot believe it. Okay. Woohoo. All right. So, yeah, it's Elaine's birthday. This was where let me find it. This one is where I made a mistake, and I kind of glanced at it and I'm like, it's not going to add up to what it should add up. And I went on to another example because it was like, 11:24 and 59 seconds. Because you all know that I'm certainly great at talking about my mistakes and using it as a learning tool. Sometimes they're intentional, sometimes they're unintentional. This was unintentional. I was just trying to throw things at you and go, see, this works. So you might notice this one. Because I'm like, see, this works. And I'm kind of looking at that going, there's no way that's going to work. There's no way that's going to add up to 60. Y'all see what I mean? Like, there's just no way that's going to add up to 60. Well, that's because it's an arithmetic sequence. It's not even a geometric sequence. Do y'all see what I mean? Like, it wasn't even a geometric sequence. It's an arithmetic sequence if you use 2n. So after y'all left, I went back and go, what was I doing? And then I realized, oh, it was arithmetic, so it was a crummy example. Okay? But let's add up the arithmetic sequence while we're here. So I shouldn't be using a geometric formula on an arithmetic sequence. It's another good reason to write out a few of your terms, okay? So in this, using this notation, this is my first term, okay? Now the formula for the sum of an arithmetic sequence is, and so it still has the same feel to it. Like, I've got to add up, how many terms are there from 8 to 4? 5. You subtract them and add 1 is, for the first one, that your initial term. So I'm taking the sum of 5 terms. And it's n over 2, 5 over 2, times my first term in this series. Do y'all see what I'm saying? Which would be 8, and the last term in the series is 16. So this gives me 5 over 2 times 24. 5 times 12 is 60, okay? My point being is I wanted the first term and the last term in the series after I started writing it, no matter what the sigma says. That make sense? I didn't have to go back and find an a sub 1. I really had my first term. Y'all seem okay with that? Is everybody okay with that now? Okay. And then I gave you some more practice on it for homework. Okay, so I wanted to clarify that. Now, before I take homework or exam questions, let's talk about the note. So I'm going to go in and pass out the note card that we want you to use this size, so you don't like get a piece of poster board and like carry it in or something. Okay. So what you can write on it front and back. You can write formulas on it, identities, and things like that. What you cannot write on it is anything with the unit circle, like the 1, 2, 3. All students take calculus. You're welcome to write that on the first couple of pages of your exam, just like you write all that stuff down anyway until you get your test. But if there's some identities you want to write on here, or some formulas like for area of a triangle, law of sines, law of cosines, you can do all that. You cannot put examples on it, which I actually think is a huge waste of time anyway, because the chances you're going to put an example on here that's going to be like one that, I don't know, what if you did cosine squared minus 2 cosine theta plus 1, and you factor it and you solve it on your note card. I don't know how this can help you anyway. You've got a tangent question, but you cannot put examples on it. These are not my rules. My rules would be you wouldn't have a note card. So anyway, these are just math department, what we sat around and what they sat around and decided. You can write front and back. You can write teeny tiny. Another thing you cannot do is find a bunch of like identities, shrink them, print them, and glue them on there. Okay, that defeats the purpose of why we're letting you have a note card. We really are letting you have a note card, something that you already know, as you barely looked at yours last year, most likely, because it prints on your brain. We're trying to teach you. It's a great study tool. I have a lot of students that once they've done this, they realize, oh, I can study for history, chemistry, whatever that way. You don't have to have a note card, but I would quite often when I was studying have some blank sheets of paper. Some girls, my BC girls, a few of them yesterday, were having, my gosh, I just can't remember those inverse trig function integrals. I'm like, get out a blank sheet of paper and try to write them down for memory. Where you stumble, look them back up, try it again, try it again, try it again until you're fluent in writing them down without missing a beat. There's something that pen to paper is it's almost like you're writing it on your brain. We also see where it is in our notes, probably, which can be frustrating, I agree. I remember in history tests, I would be able to see, where the 38th president's name was on my notes, but I couldn't think. I'm like, I know it's right there in my chemistry notes, but yeah, it's very frustrating. But so you can't print and glue and tape. You stand the risk of us checking your note card before or after you turn it in. If y'all remember, you turned it in with your exam last year. So just abide by the rules, okay? So you're writing front and back. You can write formulas, identities. That's about it. If you have a question, just ask me. I think it would be fine to write things like, let's go ahead and say what's okay to write from your memo page, identities. Like sine is x over r, cosine's y over r kind of stuff. No 1, 2, 3 chart, no all students take calculus, because that's our way of doing the unit circle. Okay. Any questions? Katie?
Can you write on the note card like the inverse trig functions, like sine and tan and cosine?
Yeah, that'd be fine. Yeah, good question. Zaina?
Should we like put our name on the card?
You'll put your name on the card. So leave a space for your name. Okay. And also, don't hire someone like Zaina out to do your note card, because if I was going to do that, she'd be the one I'd go to. If you've seen her homework, and I think she's done like a semester on a page and a half, quite thoroughly actually. Then I would need like some glasses or something to read it. But in all seriousness, don't just copy someone's note card. Obviously, you're probably going to talk to each other and go, what'd you put on your note card? But write it out yourself. You want to be thinking about it while you're writing it. It's your study tool. All right, other questions, Zaina?
Other than like the identities and stuff that they put on, are we allowed to put like actual like sentence? Like let's say I have to just remind myself something in like word form, like in a sentence. Can I put that?
Like, don't forget to do something. I think you could write yourself a reminder.
Yeah.
Yeah. The main thing is we just want to make sure that for memory you're doing things like sine of pi over 3 is square root of 3 over 2. And, because there will be 1 or 2 non-calculator pages on the honors. in which we have it all written. Mr. Hill read it a couple of weeks ago, but we just haven't got the numbers in the right order that we want them in yet. But we'll have the non-calculator stuff at the beginning most likely, and you'll have to turn that page into one of us before you can get out your calculator. So that page got to be off your desk. That's why we don't want unit circle stuff on there. We just want to make sure you know it. Any other questions? Okay, while I'm talking about that, your next memo quiz is just going to be probably full of stuff like this. Because you know I'm kind of frustrated with the IOU chart, not a fan. Thank you. If you mess up your note card, we have a few extra. Okay, so I'd much prefer that you do something like this than the IOU chart, just because it's better for you, okay? Now, does it really matter that I made that what's called a unit circle? What would happen if the radius was, if this was 5, 0, 0, 5, negative 5, 0, 0, negative 5? What would the radius of this circle be? The radius would be 5. Does anybody know why we use the unit circle? I didn't know when I was, in fact, when a lot of people use it, they get confused with the circles not have done have a radius of 1. Anybody know why we use the unit circle? Rebecca?
That's a small ratio.
Yeah. Like if I write them all with 5, they would all reduce down to the 1/2 square root of 3 over 2 stuff. This is going to also do the same thing, okay? But anyway, like for instance, if I do tan of 180, I see this in my head. I know tangent is y over x, so tangent of 180 is 0. I much prefer that you either have that on your piece of paper if you're taking a quiz, or that you see this in, eventually you should see it in your head. Like when I'm doing sine of pi, in my head I automatically go to pi, and I know my x and y coordinate, I'm ready to go with sine of pi. There is no y coordinate, is there? So sine of pi is 0. Cosine's x over r. At pi over 2, is there an x component? So it's 0. Sine of 270, what's my y component? Negative 1. Do you see how fast that is? I just don't feel like you're fast enough at those with the IOU charts, cutesy and everything, but I just don't see that that's helping. Please try to morph over into that with your quadrantal angles. You'll be a lot faster and a lot better, a lot more comfortable. Okay, any questions on last night's homework? It was like, I assigned that based on our last conversation in our last class. Everybody okay on that? Checked your answers? Okay. All right, so let's pull up the review in case you haven't done that yet. The paper review there's a cat somewhere. There it is. Okay. It's kind of a pretty funny meme. Let's see. Oh, I didn't realize this was all still here. I don't believe those are hang on. I haven't put this year's review solutions. A lot of that probably matches. But let me make sure that I have the right one. Let's see. This may be left from last year. Wish I could tell when I had posted this. I didn't realize that other stuff was in there, actually. Did I email you and post it, or did I just say it was on the
You
topic?
also, yeah, but then it was also.
Did I attach it to an email?
Yeah.
All right, well, does anybody have it printed off yet?
Yeah.
Will you check and make sure that I'm on the right one? This looks familiar.
Yeah, it's the same.
Okay, I need to get rid of the other one. The solutions that I must have posted probably match this a lot, but I tweaked it more for this year. So if something looks different, let me know. Okay, so any specific questions if you've looked at it yet? If you haven't, I'll just start to pick and choose some things to go over, but any specific questions? I mean, not on this page, but if you've looked at the review. Did anybody come today with a question? Okay,
No,
Carly?
it's just like more of a general question like I would review, but I kind of forget how to graph tan.
Let's find one of those. Okay. Or we may want to do one of these. I think there's a few that I had graph. You will need to have trig graphs.
I have an example if you need it.
No, now I'm just kind of wondering if I put them on here.
There's also part 2.
Yeah. I don't remember where I put stuff. Oh, that was more inverse trig. And I don't think there's any graphing on that. So make sure that you know trig graphing. That's obviously going to be a part of it. Okay, so let me just make one up. So make sure you know how to graph trig functions. There are questions definitely embedded in there that ask you these things. Like you'll see some questions like in the review, what's the period, what's the amplitude? But a free response could be to graph, any of the trig functions and talk about them. So, and it does come up in one of the reviews, but I think it has to do with sine or cosine. So that doesn't mean I wouldn't ask tangent. Okay, so if I have y equals 3 tangent of 2x minus pi. Okay. So this doesn't really have amplitude. It has a stretch of 3. It has a period of pi over 2. So my count is going to be pi over 4. And the phase shift is pi over 2. And in fact, I want to change this a little bit. Sorry. I don't want the phase shift to be the same as the period. Let's say this is minus pi over 3. Okay. So it has a stretch of 3, period of pi over 2. I'm going to count by pi over 8. And my phase shift is going to be 2x minus pi over 3 equals 0. 2x equals pi over 3. X is going to be pi over 6. And it has no vertical translation, so my vertical translation is 0. These are the most important things. That's my target. Pi over 6, 0 is my target. All right, so I'm going to go to pi over 6, 0. And if you don't plan ahead on an exam or a test, you've got to redraw it and make sure it's drawn to scale. And I'll talk more slowly about how I expect you to know how to count. So I may even want to think I'm counting by pi over 8s, and I'm starting at a pi over 6. So I want to think about the relationship of those two. Pi over 8s are smaller or bigger than pi over 6s?
Bigger.
Pi over 8s
Oh, pi over 8.
be smaller than pi over 6s, right? Do y'all see that? Okay. So anyway, I'm going to start at pi over 6, 0. This is my target. If it was, sorry, I was thinking about moving that up. Okay. If it was any of the other 5, sine, cosine, secant, cosecant, cotangent, see my fingers? These are all the CSCs. It would go 1, 2, 3, 4. Okay? If it was any of the other 5. But with tangent, wow, this view is horrible, sorry. I've lost everything that I need. Darn. What's just happened?
Doesn't it go like too far too back?
Yeah, but I need to, there. Okay. I don't know where all my, There, everything's there. Okay, sorry. So I was looking for my undo button. With tangent, it's 1, 2, 3, 4. Okay, now I don't know how big they're going to be. We're going to look at our common denominators in a minute. But I've got to go 1, 2, asymptote, back to asymptote. Let's get our common denominator, which would be 24. So this is 4 pi over 24, and this one's 3 pi over 24. So I've got it marked off to 4 pi over 24. And so when I count back to, what's 4, back 1, 2, what's 4 pi over 24 minus 3 pi over 24? Pi over 24, which must be just right after 0, right? And pi over 24 minus 3 pi over 24 is negative 2 pi over 24. These two are going to be pi over 24, pi over 24, and 3 pi over 24, 7 pi over 24, and 10 pi over 24. It's interesting, in all the zillions of years that I've taught this, I have only a very few students that actually use decimals for this. But decimals are a little, I'm not proposing that you do that right now, okay? But the decimals, you really know where they are. If they made their period, made their phase shift pi over 6, whatever 3.14 over 6 is, 0.57 something, anyway. And if you did it in decimals, you'd actually see that those are landing in the right place. I know that some classes do it more in degrees. You could do all of this in degrees, but it wouldn't have a pi over 3 in it. It would have something else, like 2x minus 60 degrees. And you could do it all in degrees, and you would see it real easily where your degrees should land. Okay, now I have asymptote at the end, and with tangent I put a dot right here on the target. Immediately to the right, if it's positive, I'll go up. And I always go back to my target. I always go back to this on all of my trig functions. So immediately to the right, if it's positive, I'll go up 1, 2, 3. And so right here, I'm going to go down 1, 2, 3. And so it's between these asymptotes. It's kind of stretched because of the stretch of 3. And then I usually want you to draw another one forward or backwards, and I'm not going to count it out now, but you would keep drawing them. So you have an asymptote as your first stop. So asymptote 1, 2, 3, 4. And I do expect them drawn to scale. Take the time to do that. Not going to be a whole lot of drawing these on the exam. There might be some. We might look at a review that has something like that on it. Mr. Hill and I care more about the application of it once we teach you to draw them. So we'll look at one of those in just a minute. Any more questions on trig graphing while we're here? All right, so that's another thing, like Zana's question about note card. You might want to write yourself a note about, tangent and cotangent periods pi, sine and cosine periods 2 pi. Tangent's the one that you go 1 back, out 2 back to. Little notes to self like that would be fine. All right, so sounds like y'all are ready to look at something else. Isabella?
Can we do one cosecant graph?
Yeah, let's do a cosecant. All right, so let's say I have y is equal to 3 minus 5 cosecant 3x minus pi over 4. I'm just making these particularly ugly because I feel like the uglier right now the better, and you'd be able to do whatever I throw at you. All right, cosecant's the reciprocal of sine, and so I'm going to say the stretch doesn't really have amplitude is 5. The period is 2 pi over 3. My count is 2 pi over 12 or pi over 6. My phase shift is pi over 12. Yeah. And vertical translation is 3. Vertical shift is 3. All right, so this is my starting place. If it was tangent, it would be my center, but right now it's not tangent. All right, so I'm going to go, I'm already thinking I want to count by pi over 6. I got to kind of plan ahead. What's the relationship between pi over 6 and pi over 12? Which one's bigger? Pi over 6 is it's twice as big as pi over 12. So I don't want pi over 12 to be very big. If I put pi over 12 right here and I actually count by pi over 6, it would be pretty far, which is not the end of the world, but I'm not going to have room to like finish my graph right now. So I do expect you to think about that stuff. If you're going to graph, you got to be good at it. All right, so this is pi over 12, 3. All right, so here's my target right here. And I'm going to count out, bless you. Let's make this 2 pi over 12. All right, so I have pi over 12 plus 2 pi over 12 is 3 pi over 12. Do you see how I'm kind of imagining where that would be? Wouldn't 2 pi over 12 be about right there? Okay, so this is 1 pi over 12, 3 pi over 12, 5 pi over 12, 7 pi over 12, 8 pi over 12. Okay. Something's wrong. Thanks. Do you know how I knew something was wrong? Thank you. I heard her saying that. That was one reason. Then I was going 8 minus 1 is 7 pi over 12. And another period wasn't 7 pi over 12. This block of time should match my predicted period. So I quit adding 2 for some strange reason. So this one's 9 pi over 12. Whoa. Okay. That was cute. All right. So this one is 9 pi over 12. Not sure what's happening. It's really kind of cute, but don't know what's happening. I've got all these extra. Sorry, hang on just a second. I just couldn't let go of that. All right, so maybe it's working now. This one's 9 pi over 12. And I was doing a quick mental check. What's 9 pi over 12 minus pi over 12 is 8 pi over 12, which wouldn't that be 2 pi over 3? Okay. So sorry about that. All right, cosecant is the reciprocal of sine that's going up 1, 2, 3, 4, 5, and down 1, 2, 3, 4, 5. If it's sine, which I'm thinking about sine right now, if it's sine, I start right on the target, and my next one would be up 5, immediately to the right. If it's positive, I go up. But this one's what? Negative. So immediately to the right of my phase shift, I'll go down. So I'm going to go down 5, come back to the center, then go up 5 and back down. If you want to draw your dotted line in, you could. And then I would probably draw some more of it and mark off the units, make sure I'm doing it right. It's going backwards and forwards this way. All right, so now I have asymptotes wherever it hits the middle line, the midline, the average, the mean. It's what that is. Remember, your weather project is the average of whatever's happening. And then your U-shapes go between, they fit right between your asymptotes. There'd be another one back here somewhere. So one thing that we expect you to be able to do, you don't have to see it on summer work for at least the AP Cal BC, maybe the AB also, is the domain of this graph. The domain of this graph is not all real numbers. Do you see all of the vertical asymptotes? Okay. So I would say I have vertical asymptotes. The domain is everything except pi over 12 plus 2 pi over 12k. Do you see this is the time I wouldn't say plus 2 pi k? So I would say at the domain of this is x cannot be pi over 12 plus 2 pi over 12k, where k is any integer. I mean, you could say pi over 6 instead of 2 pi over 12. And so that by default, I would say x can't be that. That means it could be anything. Does anybody know the range of this? Think about it. What would the range be?
Greater than upper equal to 5.
Okay, so my y's are greater than or equal to 5 and less than or equal to -2. You could say negative infinity to -2, and inclusive. Yeah, I included. Negative infinity to -2, and then it skips from 5 to infinity. Y'all see what I mean about domain and range? The domain and range of sine, and you can see the white sign in there, of sine and cosecant are definitely reciprocals of each other. They share their maxes and mins. They share those points. Okay?
Range for the y is greater than 5. How do you get 5 if it starts at 3 and it's like 5?
Oh, thank you. That would not be 5.
Okay.
Thanks.
Oh, 8.
8.
Oops.
Because it would be a combo of these numbers, right, Elena? So it'd be a 3 plus 5 and a 3 minus 5. You can look there for your range
Okay.
all the time. Thank you. Okay. Hey girls, if this were a sine graph, what would you say the amplitude is? 5 or -5? The amplitude would be 5. Amplitude is how far it's varying from the norm. It's a distance, okay? The sine makes you go a certain direction. But if you think about why that is, these graphs go on and on forever like this. Say there's a norm, and it varies from the norm like that. There's not really an axis out there in the real world, like as a AM radio signal is coming in. Do y'all see how it's just got an amplitude that's coming at me? Okay. All right, other specific on the review. Bless you. All right, let's do the true false. Let me pull it up. Okay. Oh, well, now I know that I labeled it. Good for me. So we know we're looking at the right one because it says 2020. I must have left 2019 up there.
Wait,
All right.
sorry,
Uh-huh.
Can we do another question after the true false?
Or before.
Oh, well, it's just like the trig function, like the solving the trig function.
Yeah. Well, let's do the true false, and then we'll do that. Okay. What time is this class over?
9:10.
Okay, we're doing great. All right. True false can be tricky. That's why I thought we would do practice some of them.
What's the solutions to
Yes. Today or tomorrow, you'll see them. And I'll send you an email so you'll know they're up. And I'll take down the other ones. They're very similar, but somebody could get confusing trying to check it with last year's packet because they're different. We didn't start with rational functions last year, so there's differences in the exams. All right, sine of 2x does not equal to sine x. That one is false. Please tell me you know that, okay? In fact, you know that sine 2x equals 2 sine x cosine x. Here you're comparing apples and oranges, though. One of these affects the amplitude, one of those affects the period. One causes a horizontal shrink, the other one causes a vertical stretch. There was a lot in all those sentences, but they're not the same, okay? Arc sine of -1/2 is 7 pi over 6 is also false. Arc sine can come from quadrants 1 and 4, and how are you, you're not going to find it in quadrant 1, and how are you going to get into quadrant 4? Can you go all the way around? The only way to get there is to drop straight down, okay? It's because your sine graph looks like this, and I can't remember who was good at this, but somebody came up and said, oh, well, it's going to exist from here to here. That's from -90 to +90, or negative pi over 2 to positive pi over 2. So arc sine of -1/2 couldn't be 7 pi over 6. All right, arc cosine of -1/2, 2 pi over 3. Where can arc cosine come from? Quadrants 1 and 2. Would you find -1/2 in quadrant 1? No, you'd have to venture into quadrant 2. At a 60-degree angle, we have a truth. The period of this is pi. True or false? False. What's the period of that? Pi over 2. False. All right, cosine A minus B. That one's false. You can pinpoint that right away because cosine A minus B should have a plus in it. It's cosine A, cosine B, plus sine A, sine B. 120 is coterminal with negative 240. That looks true to me. Okay. Tangent plus 1 equals secant. False. It's got to be squared. Okay. Tangent plus 1 wouldn't look anything like secant. Remember this. I'm always wanting to teach while I'm reviewing. Tangent looks like this. If I move that up 1, it's still not going to look like secant, girls. Right? I mean, I want you to see the common sense behind this, which I didn't see at your age. So, you know, I'm always showing you pictures. And what about tangent squared x? If this is tangent, what would tangent squared look like? These would be squared and change a bit. Not a whole lot, though. 1/2 squared would become 1/4, but 1 squared would still be 1. And these would mirror that, wouldn't it? Okay. So all of a sudden, these little U-shapes make me think about secant and cosecant. This is what secant looks like. Secant looks like this in black. What would secant squared look like? 1 squared is 1, and these squareds would change a little bit, but not a whole lot. And where would these go? So can you see what would happen with tangent squared x plus 1? It equals secant squared. Sorry, that was a bit much for that. That one was false. All right, cosine of pi over 2 minus x equals sine x. That's a cofunction, it's true. Okay, cosine of 90 minus, those are on your memo page, aren't they?
Yeah.
Or the graph would also match. Sine is an even function. False. Sine is an odd function. Which one's even? Cosine. F of negative x equals f of x. Cosine of 180 is negative 1 is true. I just saw in my head cosine of 180. Do y'all see my x-coordinate? It would be negative 1. A triangle has only one obtuse angle.
True.
True. Well,
But can it not have much to say though?
yeah. Wonder what I said on my key. I put true. I don't know that I was.
If it
Well, it can only have one. It can't have.
Maybe it should be worded a triangle can have only one. Or can't have more than one. Anyway, you get the point. We'll be really careful what we put on the exam. If there's one that's hard to read, we would make an exception on it or something. Whatever sign is, that's false, right? Every trigonometric graph has zeros.
No. Secant and cosine.
Well, even a shifted sine and cosine doesn't have to have zeros, do they? Did y'all see what I mean? Okay. A tangent graph would always have zeros. What's its range?
It's all
Negative infinity to positive infinity. A tangent graph would always have zeros. You couldn't move it and it not have zeros. What about secant and cosecant? I think they'd always have zeros. I don't think you could move them to where it wouldn't. Oh, you could. I'm sorry. Just the ones that are on the axis would not have zeros, like this. I was thinking of shifting them up and down. But anyway, that one's false. 5 pi over 4 in radians is 225. True or false? True. Okay, while I have this one here, let's do this. These are ones that you would expect to draw a triangle, and there's a few of these on the review packet and probably on the exam. So sine of t is negative 3/5, and secant t is greater than 0. Let's change that to cosine is greater than 0. So if sine is negative, I'm either here or here. If secant and cosine are positive, which quadrant am I working in right now?
first.
fourth.
Sine is negative, so I'm here or here. Cosine is positive, so I'd have to be in the 4th quadrant, right? Okay. All right, so now I know I'm in the 4th quadrant, so draw your triangle in the 4th quadrant. Some of you on your test, when we did this, We're not drawing your triangles correctly. Make sure you're doing the bow tie kind of triangle in the correct quadrant. All right, sine is -3 and 5. When I do the Pythagorean theorem, I'll get plus or minus 4, but from my picture, can you see it would be 4? And I can use that picture to answer all sorts of questions. Cosine t, cosine of 2t. I could use this for lots of things, okay? Tangent would be -3/4. Cosine would be 4/5. And cosecant, you surely don't want to miss that one. You don't even need a triangle for that. Would be -5/3. So there's the first page. All right, now what are we going to, Nicole? I've forgotten what you wanted to
Like
do.
the trig, like the solving the trig functions. Like we
Solving
do
trig
like,
equations.
where
Okay.
there's like a sine and a cosine. But like
Okay.
that's where-
So let's see. There'll be some of that in here. Here's one. Sine 2x plus cosine x equals 0. We'll do a few of these. Sine 2x plus cosine x equals 0. Help me remember that. Okay. So sine 2x plus cosine x, is that what I said?
Yeah.
All right, sine 2x, I would change that to 2 sine x cosine x plus cosine x equals 0. Then what would you do? First thing you should always do is factor out what's in common. So I'm going to factor out cosine, and that leaves me 2 sine x plus 1,
And then
which
equal
gives
those.
cosine 0, and sine's -1/2. Okay? Cosine is 0, I see it in my head at pi over 2 and 3 pi over 2. How did I see that? I know that right here is where I don't have any kind of x-coordinate. My x-coordinate is 0. I know cosine's x over r. And then sine is -1/2
7 pi over 6.
at 7 pi over 6, great, and 11 pi over 6. And it's a multiple choice, so we'll click back on that. But if I said solve on 0 to 2 pi, we're done. If I said find just solve, you would say plus 2 pi k, where k is any integer, all right? In this case. So what was our answer choice? So we would pick, which one's not a solution? So would be 5 pi over 6. Granted, on your multiple choice, you could just start filling them in and see if they work. But I think a lot of you just feel more comfortable. I don't even think you're going to do that. You're probably going to work it out or come back to it or
Can
something.
we do
Let's-
number 8 on the next page?
All right, so we're doing number 8 on this page. All right, so 2 sine x plus cosine x minus 1 equals 0, and we are in degrees. That one I don't think we can solve by hand. That would be a calculator active problem. 2 sine x plus cosine x. I can't think
So
right
I feel
now.
like I'm plugging into the graph.
Yeah, so we need to talk about that. I already forgot what it said. What did it say?
2 sine x plus cosine x minus 1 equals 0.
All right, there's no way to get like the same word in there because nothing's squared. If I had this, what if I had sine x minus cosine x equals 0? I would give you that on a non-calculator page. How is it possible for sine and cosine to cancel each other out? They would have to be the what? They'd have to be the same, which means it'd have to be an isosceles triangle at a 45-45 ratio. So it would happen in the first quadrant at pi over 4. Why wouldn't it happen in the second quadrant? Yeah, when you subtract them, one of them would become a positive, like you double it instead. So in the first quadrant, you have root 2 over 2, root 2 over 2. In the second quadrant, your cosine is negative root 2 over 2, and your sine is root 2 over 2. So if you say sine minus cosine, do you see you would end up not getting 0? But in the third quadrant, wouldn't it happen again? If you subtract two things that are the same, you get 0. So that would be 5 pi over 4. We expect that kind of reasoning. okay? If I wanted to give all solutions while I'm on this one, I would probably just say pi over 4 plus pi k. Because do y'all see I picked this one up on the way around? Do y'all see what I mean? So anyway, that's a little side note. What if, back to this one, you didn't see what Rebecca saw, and you thought, well, I'll try to solve it. Sine x equals cosine x, what would you do then?
Plug it into the calculator.
If you don't have a
If you
calculator.
have- Oh.
I'm going to divide by cosine x. Yeah, you really see it then. If I write sine x equals cosine x, you really see you need the first and third quadrants.
Yeah.
And that may call to mind, if you didn't see what Rebecca saw about them canceling, once you set them equal to each other, you might go, oh, well, that's got to be at 45s. Okay? But if you don't see it then, you could divide by cosine, and where's sine over cosine equal to 1? By then, hopefully, you've arrived at a 45-degree angle. Do y'all see what I mean? Okay. All right, back to this one. I don't see any way to rearrange that one algebraically, in which case then you grab your calculator. And so where are we with our calculator usage in my class? Y'all would tell anybody that you don't use it very much. You prefer to do it by hand. It's faster to do it by hand. If I see one, like the first one, I'm not going to turn on my calculator. I'm going to solve it myself if I can. I might check it with my calculator. In AP, though, you're going to face stuff like this and they expect you, obviously, to use technology in the year 2020. We can all argue the fact that there's no way we're going to get this right if we don't understand trig functions. I mean, just because I hand you a calculator. In fact, you're probably a little bit scared of them and you use them more than a lot of people do. First of all, I've got to put it in degrees because of the way the problem is worded. This calculator always takes a bit to turn on. In AP, you'll know when and when not to use a calculator because the exam is structured. There's 28 questions without a calculator and 17 questions with a calculator. This year, I think there's 15 with a calculator. And also, if you have decimals, you know you're not going to come up with those without a calculator. Like if you see answers like 0.789, okay? This isn't a multiple choice. We can work them faster by hand if we can work them by hand. But I would have no hope of getting this right without a calculator. I almost did my slides today. I don't know how, just forgot her name. From Hidden Figures that just died this week. She was 101, I think, years old. And I'll have her on slides later, just because if you've all seen, I hope, Hidden Figures.
Yeah.
But did you see what really, one of the, obviously their mathematical skills really propelled them into great jobs. But do you remember the manager, the lead woman that, she got them on computers? Do y'all remember?
Yeah,
Who's seen the
she
movie?
wanted them to be like a
Yeah, she's like, let's learn the language, let's learn how to program these computers. It's going to be the next greatest thing. And the more that we can do with technology that's based on mathematics, the more that we can do. If we can't use technology with mathematics, we wouldn't be where we are in 2020. I almost wish we weren't. You know, I wonder what the world would be like if we didn't have social media and cell phones and everything. Someone would want to throw mine away. But let's go mode, check our mode. I want to go in degrees. All right, I'm going to make my window 0 to 360. Since I understand trig, I'm thinking I don't really want to go very far. I a lot of times go from -5 to 5. I have an awareness of the amplitudes that are in my equation. And I have sine x.
I have a question about that.
Hang on just a second. 2 sine x plus cosine x. Not in the right place, sorry. Is it plus cosine x minus 1? And so I'm going to graph it, and I quite literally want to see where it equals 0. And so sometimes I actually will even go to table and fill in a number I suspect. Like it looks like to me 0 gives me 0. But if I don't want to fight with y'all see 0 does give me 0? So sometimes I don't like fighting with Calc 0 and Calc Intersect. But again, these would be skills you have to have in AP. So Calc 0, I think this is using a program actually based on Newton's method. They took Isaac Newton's mathematics and made it a program so that we can find our zeros. To the left, to the right. On gas, I don't. I just hit enter. And I get 126.869 or 870 degrees. So I have 0 and 126.870 degrees. And I check that answer. Yeah. And those are all of the answers from 0 to 360 inclusive. I think the bracket was on the 0. Okay? All right, Nicole, another question?
Yeah, I was just confused, like, when you did the window, like, I always thought that the window values were just, like, normal numbers. Like, and then, like, so, like, the 360, I know you put in, like, 2 pi when it's in, like, radians. Like, I don't know why the 360 is, like, confusing to me.
Except for me to find all the answers from 0 to 360. If I'm in degrees, I'm in a whole different ballgame. Like, for instance, if I'm in degrees, which some classes graph in degrees. So with, I think Chloe's question with tangent, and if I was going to use my calculator to check my tangent graph, which would be a really bad idea, you'd probably be wasting your time. But Nicole, if I'm on like a standard viewing window,
Yeah.
I'm going to go, oh,
Yeah.
darn. Like, what is happening? It's because I'm only going out 10 degrees. So you got to have a real awareness of what it is you're trying to look at. If I'm in degrees, I want to go out to 360 or 720. If I'm in radians, that would be horrible.
Okay.
I mean, so if I make my window negative 720 to 720, because once again, I emphasize, to me it really taxes, do you know what you're doing? It really ascertains, do you know what you're doing? I know what I'm doing. I feel good about my tangent graph. If I don't know what I'm doing, I'm going to be fumbling around with everything and getting frustrated. Watch what happens if I change my mode to radians. Girls, 720 radians is a long way. All the way around the circle is about 6 radians. That's not going to be helpful, okay? You're going to get, and people will do that if they don't know what they're doing. They'll be really frustrated. You know what you're doing. The good thing is in AP, we stay in radians all the time if we're doing trig functions. And even with polynomials and some transcendental functions, they almost always give you a window. Y'all can start. Let me grab your thing and explain. Y'all want to just sit outside for now or grab a chair in here? Or you can sit in my chair, you just got to clear my desk and not. Come up here though, let me show you something. Sorry, let me get them started on a test they're still taking from yesterday. Because, alright, these little equals once again didn't run off very well. These are all equals. Alright, and the year that, if Grace Hooper's listening to the video, she's going to wonder what I'm doing right now. Hi, Grace. Okay. So, some students that year just looked at the picture, and they didn't read the words. It's the region in the first and second quadrants. So this is R. Okay. And S is this one right here. Just the part in the first quadrant. It doesn't go over. So I don't want you to miss it for not knowing where things are. So you're finding the area of S, the volume when you just revolve R, and then some cross sections in R. So you're dealing with exclusively R, S in the question.
Okay.
Okay?
Thank you.
Make sure your name's on it.
I'll sit outside.
Okay, so does anybody have another quick question on the review? Okay, so like I said, I'll post the answers, so that you can check and see how your work is going. email me with questions. You can send me screenshots. This is how I've gotten so far. What am I doing wrong? Or come by and see me. All right?
Thank you, sir.
Bye, girls. This is like the first time we've ever ended before.
Yeah, like ever.
I don't really know how to do this. It's a miracle. Oh, you didn't see my last slide. There. Isn't that cool?
Yeah. Thank you.
Bye, girls. Study hard. Check assignments in case I put a quiz up.
I'd rather put just like a few words in Spanish on my phone. Like you can not in a sentence, like just like 4